Hi, Al Williams here. Another quick and dirty video, so don't get too critical of my production skills here, but it was mentioned that the 1802 Uno was hard to operate from the serial port, and I can't deny it, but I thought it might help to actually have a little video of the process. So if you're not familiar with it, the Kim Uno was a board that has a Arduino on it. I didn't design it, and it was made to simulate a Kim 1, which was an old single board computer with a 6502 on it. So it's got a hex keypad and it's got 8 keys on it and some LED displays. Now, normally you pick it up and you use the hex keys and you program it, but it's also got a connection to the Arduino, which means it can have a serial port. I wrote firmware for that to convert that from a Kim 1 into a RCA 1802, COSMAC ELF kind of computer. And because of the Arduino, it's fairly limited. It's got a couple of ROMs in it, and it's got about 1K of RAM. Well, I say about, it's got 1K of RAM in it, which is actually more than the original ELF, but still. There's a bunch of commands you can access over the serial port to do things like load hex files and dump memory and even enter into a full-blown, actually pretty nice debugger. I'm not going to cover those. You can go look at the GitHub page and read the documentation for that. But I did want to say, how do you get started with this? So if you look at the Kim keys, there's several keys that are marked on the PC board. There's a Go, ST, RS, SST, AD, DA, PC, and Plus. And so those have meaning to the Kim 1, and I have kind of hijacked them for the 1802. So the Go key is run, and we'll talk about what that means in the serial port in a minute, but the Go key is run. The ST key is stop. That makes sense. RS is reset. SST is single step. The AD button lets you set an address by punching in some hex keys and then hitting the address button. The DA puts you into load mode, so data, load, who knows. And the PC button lets you turn on memory protection. And you look in the documentation, there's some LEDs that will show you you're in load mode, you're memory protected, whatever. And then the plus key is the EF4 input key. And that's the only one that's a little tricky. And then also, if you hold the DA key or hold the AD key, it will save RAM into EEPROM or load it back. Again, go read the documentation. But on the serial terminal, there's a couple of different things. There's the G command, that's go. S is for stop. R is for reset. A / is single step. The equal sign is set address. L is for load mode. P is for memory protect. So all those kind of make sense. They're all documented. The only thing that's kind of weird is the EF4 toggle switch, because normally you want things where you can hold that down and let it up in some cases. So the $ toggles the state of EF4. So what that means is to enter something in load mode, you actually have to hit $. And then there's some additional commands that from the serial port. I'm only going to talk about a couple of them. The exclamation point echoes back what you would see on the LED displays. So if you don't have LED displays, that's the way to look at them. For instance, if you're just running it without a Kim Uno board, just on a regular Arduino, and the star, the asterisk, will dump out everything about the processor. And then last, if you want to use the thing as a serial port instead of this weird command mode, you put in a vertical bar, and then after that, until the Arduino resets, not the 1802, but the Arduino, so like a hard power reset or reach back there and hit the reset button, then at that point, it's a terminal. It's 9600 baud, 8 bits, no stop, or no parity, one stop, and that's it. So it'll be a serial port from then on. So sometimes you'll do something like load the idiot monitor, and then you want to use it as a terminal and you want to use the monitor. And honestly, that's the best way to use this with the serial port. But if you want more of the authentic thing, I'm going to show you how you can actually use this. So first of all, let's look at the displays. That's the exclamation point. And for some reason, mine has a 17 on it. I don't know what I was doing, but it's got a 17 on it. And if I wanted to see the state of everything, I can actually hit the star button, and I'll get a whole bunch of, what the registers are, DR, DF, the X register, the P register, and the Q output. So everything you need pretty much is there. So let's go into load mode. And if you do have LEDs hooked up to it, you'll see the LED for load mode comes on. And as you type hex characters, they're going to show up in the display. So I'm going to type a little program here. I'm going to type F8, and then I need to do a $sign. I should have turned echo on. So since this is Minicom, I'm going to turn local echo on, which is E. Okay, so you'll be able to see the rest of this. I'm going to type in $00. Okay, it's important to put both the zeros in because you're kind of shifting things into a register. So you can see that very clearly on the display when you hit 0, like in the last example where it was F800, that first 0 key, now you have 80 in there. So you got to put both zeros in there. I'm going to put B2 $. Excuse me, F8 $, FF $, A2 $, E2 $, 64 $, 22 $, F8 $. Oh, whoops, I messed up. Just keep typing then. So 09 is not what I wanted. I wanted 01 there, $. As long as you don't hit the dollar, it's in there. It just shifts over, so that's fine. F801, I want to do an F4 $, 52 $, and then last but not least 30 and a 07 $. Now, what does that program do? Well, it loads a 0 into the accumulator, stores it into the high part of R2. It loads FF into the low part of R2. It changes the X register to 2. It does an output, and that output takes the memory that's at the location in R2, and then it also increments R2. So we decrement R2, then we load 1 into the accumulator, we add it to the memory in R2, we store it back to the memory location at R2, and then we branch to 7 and do it all over again. So if this works, it's going to display some sort of hex number, whatever's at location FF, on the display. Then it's going to increment by 1, and it's going to jump and go do it again, and it'll just keep rolling over. So it'll go, 1, 2, 3, 4, 5 all the way through. Now, if I wanted to, I could go move over to location FF and preload it. I don't care in this case. Also, it's going to be pretty fast, but since we can't see the displays anyway, it doesn't matter. So to leave load mode, I can either press S to stop, or I can press R to reset. Doesn't matter. So now we want to do the go command. And if I had a camera on it, you would see that the display's going crazy. But we don't have the board supposedly. So let's do the exclamation point so we can see the display. So every time I hit the exclamation point, I can see, sure, there's another number. It's pretty hard to see that it's incrementing by 1 because obviously the time between me hitting the exclamation points is enormous by relative to the CPU execution. I could also look at the state with the star button, the asterisk button. And so you'd have to scroll a little bit to see all this, or maybe turn off some of the carriage returns. Well, I can scroll up here. So you can see R2, in fact, does have FF in it. So that's pretty cool. There is ways that you can get into a monitor here, and we could do things like single step it. Without the displays, I don't know if that's that useful, but it could be. So I could hit S to stop it. And if I look at the display now, it's got a 20 on it. And I could say single step. And now let's look. I just happened to catch it at the right place. Whoops, sorry. I'll do another single step. But if I do an exclamation point, sorry, then now I've got 22 on it. So just happened to catch it at a good spot. If I single step again, you can see the code executing on the displays. So you can watch the address change. I don't know why I keep hitting D. Sorry. Well, I told you this would be quick and dirty. So the exclamation point there, you can see location 7, and we've got a 23. And so if you go work all that out, 7's the output instruction. So on the next single step, I'll just keep pushing through over and over again. So a lot of things you can do here. Again, if you wanted to use the serial port, you would use the vertical bar, and then at that point it just becomes a serial port, and it can be read through a fake BIOS that the board has. So it really doesn't run 1802 code to read and write the serial port, but the code that calls the BIOS will just get the right characters back from it. So all in all, pretty fun. If you've got the hardware, it's more fun, no doubt about that. But if you just want to play with it, that's fine. My plans are to try to move it to a larger chip like the Black Pill, where you could actually put like a full monitor ROM with BASIC and Forth and all that good stuff in it. And maybe I'll get to that soon. But until then, this is one way to get an 1802 if you just happen to have a spare Arduino laying around. The original work for the Kim was very valuable, so a lot of the framework is from that piece of code. And then I, of course, modified it. Oscar took one of my original versions and made it where you can hook up a I2C OLED display, one of those little bitty OLED displays that are very cheap, and you can hook that up to 4 pins on the expansion port, and it will emulate the COSMAC ELF graphics. So you can run all the programs with the, the Enterprise, and it says 1802 or whatever, the things that you saw back in Popular Electronics back in the day. Of course, you'd have to have the software to do that, and that's included in that build. That build is also on GitHub as a branch. Unfortunately, the code bases have diverged a little bit. So the 1861 code, I think that's the right number, the Pixie chip code is not integrated with the mainline code that has a lot of the same features. And if you ever wanted to do that, you need to do it yourself. And then I would be very grateful if you'd push that code back as a pull request, because I'd like to get it integrated. It just really hasn't bubbled up to the top of my priority stack. I mean, realistically, having a little display is cool, but it's not really very useful. And I've really focused more on making this a debugging platform for writing 1802 code that's going to later run on a real piece of hardware. So anyway, I hope you enjoyed that. If you've got an Arduino, give it a try. If it doesn't work, let me know. We'll help you get it going. So thanks for watching.